Good morning, everyone. This is for Math 35, College Algebra. I'm going to cover Chapter 3, Section 2. This is on synthetic division. And so let's just get started. Let's show you how we did a problem back in the days. Before we had synthetic division, we did this. So let's just set up the problem. This involved doing polynomial division. So we have 4x cubed minus 15x squared plus 11x minus 10 over x minus 30. Now, I'm sure many of you did not like doing this because it was a pain in the butt. I agree. Recall, we'll do an example in a little bit. Any term that's missing should be present with a coefficient of 0. With a coefficient of 0. And how did we do division? Well, we took the denominator, we wrote it out front. And we put the numerator inside. And if you recall, the first thing we wanted to see is how many times x goes into 4x cubed. 4x cubed divided by x equals 4x squared. I'm going to put that up here. I'm going to take the 4x squared. I'm going to multiply it by everything in front. 4x squared times x is positive 4x cubed. And 4x squared times negative 3 is negative 12x squared. And then when we did normal division, we subtract whatever we did. So I'm going to put the subtraction thing in. And I'm going to move the subtraction sign in, just change the signs of each of these inside. So that when I add them up vertically, I got 4x cubed minus 4x cubed, and they go away. And then I have negative 15x squared plus 12x squared gives me negative 3x squared. And I'll bring down the 11x. And we repeat this cycle. Now we'll see how many times x goes into negative 3x squared. And it leaves behind negative 3x. I'm going to take the negative 3x. I'm going to multiply by everything out front. And again, I'm going to do the subtraction, where I move the minus sign in by changing all the signs inside. The negative 3x squared and the positive 3x squared cancel. I have 11x minus 9x is 2x. And I'll bring down the minus 10. And we'll finally finish the process. How many times does x go into 2x? We divide the 2x by x, and we just get 2. Since it's positive, we'll put plus 2. I take the 2, I multiply it by everything out front. I subtract, and it changes the sign of everything inside. So positive 2x goes to negative 2x. Negative 6 goes to positive 10, or positive 6. We add, and the 2x minus 2x cancel. I've got negative 10 plus 6 is minus 4. There's nothing left to divide into. The biggest exponent in here is 0 for x, and it's 1 out here, so we stop. This is our remainder. And what we say is, this is our result, 4x cubed minus 15x squared plus 11x minus 10 divided by x minus 3 equals what we have on top, our quotient, 4x squared minus 3x plus 2. And then I'm going to add the remainder. The remainder is negative 4, and it's all over the old denominator. I'll pause and let you absorb that for a second. All right, you guys ready to see synthetic division? Do this an easier way. So same problem. We already know what the answer is going to be. 4x cubed minus 15x squared plus 11x minus 10 divided by x minus 3. I'm going to call this denominator here, this is x minus k, because we want this number right here, and it's the opposite sign of whatever's present. So in this case, k equals 3. What we're going to do is we set up a box. I put all of, and I'll write this down as I'm doing it. So step 1, put all of your coefficients in the top row of the box. So I've got 4, negative 15, positive 11, negative 10. Okay. Keep my mouse out of the way. Step 2, write k in front of the box. Remember, it's the opposite sign of what's there. Step 3 is even easy. Bring the first number down unchanged. All right, you guys with me? So this is where it starts to get a little different. So what we're going to do is step 4, multiply k, which is out front, by the last thing brought down. And add it to the next column. Write the sum below. This is like bringing down the next number. Okay, so I've got k. K is 3. I'm going to multiply by the number I just brought down. 3 times 4 is 12. I'm going to add 12. Negative 15 plus 12 is negative 3. Okay. For step 5, repeat until you're out of columns. Maybe I should say repeat step 4. Repeat step 4 until you're out of columns. So 3 times negative 3 is negative 9. 11 minus 9 is 2. 3 times 2 is 6. Negative 10 plus 6 is negative 4. Now, if you look at our last answer, this bottom row looks very similar to what we had. What did we have? The last number in the bottom row is the remainder. The other numbers are the coefficients for the polynomial 1 degree lower. Click pause for a second so you can finish writing that down. I want to explain what that means. So the numbers I had, my bottom row, was 4, negative 3, 2, and negative 4. And the problem was 4x cubed minus 15x squared plus 11x minus 10 over x minus 3. Right now, this is a polynomial of degree 3. The degree is the highest exponent. So these will be the degrees of 1 less lower. This will be a polynomial of degree 2. which means 4x squared minus 3x plus 2. And then we had our remainder, plus negative 4 over x minus 3. Yes, you can put the negative here. The only reason I don't do that is sometimes this gets a little chaotic and it's a little confusing whether it's positive or negative, and writing it this way, there's no confusion as to where the negative is. So that's how synthetic division works. And if you go back up through your notes, you'll see that's what we had before. And you know what's kind of neat? You can check your work, find out. Check this out. So let me rewrite that. I've got 4x cubed minus 15x squared plus 11x minus 10 over x minus 3. And on the right side, I've got 4x squared minus 3x plus 2 plus negative 4 over x minus 3. Now what I'm going to do, I'm going to multiply both sides by the denominator. Okay, so the x minus 3 here and the x minus 3 here cancel. And I get 4x cubed minus 15x squared plus 11x minus 10 equals. And what I'm going to do is I'm going to distribute this x minus 3 to this set and to this. That's what I'm doing in this next step. So I'll have, I'm not multiplying it out yet. I'm just writing it like that. That's doing the x minus 3 times this part. No operation's been done. I'm just splitting up the second parentheses. When I do x minus 3 times the negative 4 over x minus 3, those two cancel and I just get negative 4. Okay. I'm going to finish working that out in a second. I do want to point out something. This leads to the next idea. This here is a function of x. Right here, I have x minus k. Here I have the quotient that's left over. So we're going to call that q of x. Quotient. And then I have the remainder added on. This is called the remainder theorem, and we're going to go over it in a little bit. But I want to finish showing you that we can show that the both sides are equal. All we have to do to finish showing it is finish multiplying that out, distributing. So let's distribute the right-hand side. I've got X times 4x squared is 4x cubed. X times negative 3x is negative 9x. X times 2 is 2x. That should be negative 9x squared, my bad. I'll distribute the negative 3. Negative 3 times 4x squared is, and that should be a positive. What did I do? Four x cubed x times that is negative 3x squared. There we go. And 2x. Distribute the negative 3. I get negative 12x squared plus 9x. Minus 3 plus 2 is times 2 is minus 6. And then I still have the minus 4. I add those up. Which is what we got right there. So multiplying it all out, just by clearing a fraction, I can show both sides are equal. This leads to an interesting idea. Pause it for a second if you need to write that down. We'll do another example. I want to illustrate the remainder theorem though. Let's go back up to that 4x cubed where I wrote it out. And I said this is f of x equals x minus k times q of x plus r. Now we showed those two sides are equal. Watch what happens when I plug in 3. K equaled 3. So I'm going to evaluate f of 3. I could do it on the left side and work everything out, or I could do it on the right side. This just says x equals 3. Replace x with 3. I have 3 minus 3 times 4 times 3 squared minus 3 times 3 plus 2 minus 4. All of this is completely unessential. 3 minus 3 is 0. So I've got 0 times that. And 0 times anything just wipes it out. And all I'm left with is the minus 4. Which is the remainder. And this is true for anything that you can write like this. If I can write f of x as a product of x minus k times another function q of x plus r, when I plug in k, I get k minus k q of k plus r. and k minus k is 0. So f of k equals r. That's why it's called the remainder theorem. So plug in a number and you'll find the remainder from division. Now, the whole main goal of this entire chapter, the goal of the whole chapter is to find the k's such that f of k equals 0. Which means r equals 0. Hopefully you paused. And what happens if r equals 0? If r equals 0, it means that the f of x divided by x minus k just equaled q of x plus r, which was 0. Which means x minus k is a factor of f of x. Now, we found ways of finding factors of equations that were second degree, quadratic equations. We learned how to factor them using a variety of techniques. This works when they're larger degree. On the problem we did this time, we started off with x cubed, and we didn't have a general way of finding ways of factoring that. Okay, I want to give you guys, we'll do a couple problems. You guys ready for some more? Okay. So we're going to work on synthetic division a few times. Let's have negative x to the 4th power plus 3x squared minus 4x minus 5 over x plus 3. And I want to ask you first off, are there any missing terms? There is. There's no x cubed. So we're going to treat it like there's a 0x cubed when we do our sky division or synthetic division. I call it sky division because the numbers are hanging in the sky and we bring them down. I don't know. It's something I learned as a kid. So I'm going to make my box. And I put the coefficients in front or on the top. -1, then I need the x cubed term, 0. Then x squared is 3. then -4, then -5. The question is, what do I put out front? Remember, it's the opposite sign. This means k equals -3, because what we really have is x minus -3, and that matches up with x minus k. So k equals -3. So I'm going to put -3 out front. I'll bring down my -1. I'll take the -3 and I'll multiply it by -1. I get +3. I'll add it. -3 times 3 is -9. I add it. -3 times -6 is +18, which gives me a 14 here. And -3 times 14 is -42, leaving me -47. So this is my remainder. These are the coefficients to q of x. And it's 1 degree lower. We had x to the 4th power. This was the degree of 4. And our solution will have a degree of 3, which means I'm going to have -1x cubed now. Plus 3x squared minus 6x plus 14 plus -47 over x plus 3. You guys ready to try one? I'll assume you click pause to finish writing this down. I want you guys try on this one. And let's go big. 5x to the 5th power minus 6x to the 4th plus 2x squared minus 3 over x plus 2. Nope, did not want that. Please pause it and try this on your own. And then we'll do it together. So the exponents that are missing, there is no x cubed and there's no x. So my box needs to have zeros in for them. Five, -6, then my x cubed, 0. I got my x squared, then I got my x, which is 0, and then -3. My k is the opposite sign. So this is going to give me k equals -2. Negative 2 times 5 is negative 10. Negative 2 times negative 16 is 32. Negative 2 times 32 is negative 64. Negative 2 times negative 62 is 124. It's getting big, isn't it? And negative 2 times 124 is negative 248, which gives us negative 251. We went from a degree of 5. Now we're going down to a degree of 4. 5x to the 4th power minus 16x cubed plus 32x squared minus 62x plus 124 plus negative 251 over the old answer, or old denominator. Ready for more? While I have a little blank room on this page, I am going to point out something. When the remainder is 0, what we have is I can instead write it, we'd have f of x equals x minus k times q of x. So x minus k is a factor of f of x. That's part A. Part B, though, if I plug in k, I get k minus k q of k, which equals 0. When we can plug in a number, and the remainder is 0, we call the number k a 0 of the polynomial. Okay. And it actually means a lot. When we start doing graphing in a later section, it's actually where the graph of the f of x hits the x-axis, which is handy. It's handy to know those things. Those are valuable things. But we did one that was kind of easy. Let's kick it up a notch. So x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5. And this is where I'm kicking it up. X minus 1 plus 2i. We're going to have complex numbers this time. So my box, my coefficients are 1, -2, 4, 2, and 5. And k is equal to 1 plus 2i. Looks a little daunting, doesn't it? A little intimidating. Just take your time, go through it slowly. This part's easy. 1 times 1 plus 2i is just 1 plus 2i. Now let's work on adding these. -2 doesn't get added to the I, it gets added to the 1. Because this has no I, this has an I. So -2 plus 1 is -1 plus 2i. And now I need to multiply that times that. I'm going to do that below. I'll distribute. 1 times -1 is -1. 1 times 2i is 2i. 2i times -1 is -2i. And 2i times 2i is 4i squared. Well, that looks kind of handy, doesn't it? 2i minus 2i, they cancel each other out. I got -1 plus 4i squared. What did I squared equal? Hopefully you remember, when we had I squared was -1. So my result here is -1 plus 4 times -1 is -5. And I lost my i's. I didn't have any i's in that step. We'll do it again. 1 plus 2i times -5. I get -5 minus 10i. Oh, damn it. I got all hasty. So now I got to do 1 plus 2i times -5 minus 10i. What the hell am I doing? Four plus -5 is -1. I'm getting distracted. I can hear my wife cooking in the other room. I'm getting hungry. Sorry, that was bad. 4 plus -5 is -1. That was the next step. And we'll do 1 plus 2i times -1 is -1 minus 2i. Two minus 1 is 1. 1 minus 2i. And now I'm going to work out 1 plus 2i times 1 minus 2i. There we go. That's the right step. This is actually a plus b times a minus b, which is a squared minus b squared. It was the difference of squares formula. So this is 1 squared minus 2i squared, which is 1 minus 4i squared 1 minus 4i squared is 1 minus 4 times negative 1 is 5. And I realized I made a mistake up here. That should have been a negative 5 right there. See? So 1 plus 2i times 1 minus 2i equals 5. And I add it up and I get 0. One plus 2i is a 0 of the polynomial. Now, interestingly enough, so what do I have as, what's my remainder? Well, my remainder is 0. What's my quotient? It's these values. So q of x, my result, I get a degree of 1 lower. So degree of 4 goes down to a degree of 3. And I get x cubed plus negative 1 plus 2ix squared minus x plus 1 minus 2i. That's my remainder. Now it's crappy looking though, right? This is where it comes out something's pretty neat. It comes up again later. It's not even in this section, but while we're covering synthetic division, I thought we'd do it here. I'm going to rewrite this as f of x equaled x minus k times q of x. So my f of x was the old numerator, x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5 equals x minus 1 plus 2i. Actually, I'm going to write it below because this is going to take up so much room. Times my remainder, x cubed plus negative 1 plus 2i x squared. Then we had minus x plus 1 minus 2i. So f of x equals x minus k q of x. So this leads to something that's really neat. This is called the Complex Conjugate Theorem. And it goes like this. Let's say z equals a plus bi. So z is a complex number. And the theorem goes like this. If x minus z is a factor of f of x, then so is, and this is a new notation, you've never seen this before, x minus z bar. Z bar is the complex conjugate of z. And what I mean by that is z equals a plus bi, then z bar equals a minus bi. We just change the sign in the middle, the sign on the I. That's what makes it the complex conjugate. Which means we could do the sky division again. In fact, I'm going to. In the notes I already have posted, I don't have the next step up. I think I gave it as extra credit to the class, but seeing as how I don't think I'm going to get to see you guys for the rest of the semester, other than through video chat, I think I should do this right now. So I had my q of x was x cubed plus -1 plus 2i x squared minus x plus 1 minus 2i. Those are my coefficients of q of x. And I had, what did we have? We had z equaled 1 plus 2i. So z bar is going to equal 1 minus 2i. It's pronounced z bar. Let's go through and work it out. You might want to pause it, try it yourself right now, get some extra practice in using complex numbers. If you guys are in college algebra, you're going to be going down an engineering road of some sort, or science, or nursing, or something of that nature, and having good math skills is essential. So pause it, give it a try. All right. Multiply it, I get 1 minus 2i. You thought this was going to be hard, didn't you? I knew you did. It looks intimidating as hell, doesn't it? But look, I get 0 when I add that up. Which means that's 0. That's -1. -1 times this just changes the signs, and I get 0. See? R equals 0. Z had a remainder of 0, so z bar gets a remainder of 0. Which means my remainder now is just x squared minus 1. So we had x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5 equals x minus 1 minus 2i, x minus 1 plus 2i, x squared minus 1. And this actually factors further. This is the difference of squares. It's the a minus b, a plus b. This is x minus 1, x plus 1. So you can factor it all the way down. When we're graphing these will be the only ones that hit the x-axis. Will be the only zeros that hit the x-axis. In a real number system, which is usually what we're graphing. Complex graphing is a whole nother animal. It's an interesting course. It's a very interesting course. It's a long ways ahead, but okay. So I thought I would look at a homework problem with you. And I chose this one because it has fractions in it. This was number 3, I think. I need my picture back up though. There we go. And now I don't see the problem. There we go. Problem 3 from homework. It's a little intimidating with all those fractions, isn't it? Unfortunately, we can't clear the fractions. You just got to work with them as is, which is going to give you some practice with fractions. I've got 1/3, -8/9, 8/27, and -1/81. Outside is 1/3. Bring the 1/3 down. 1/3 times 1/3 is 1/9. And here we only combine numerators. -8 plus 1 is -7/9. So now I've got -7/27. Multiply 1/3 times -7/9. You get -7 on top, 27 on bottom. Add these up, I get 1/27. And they conveniently gave us numbers that combine well. At least they didn't give us fractions that had different denominators and we had to do even more work. We've got a remainder of 0. My answer here is a degree of 1 lower, 1/3 x squared minus 7/9 x plus 1/27. Oops. Oop, darn it. It's good. Oh. And I thought we'd take a look at this one. This is number 5. So I get f of x equals 5x cubed plus x squared plus x minus 6. And they'd say k equals -1. And they want us to express f of x like that, which means we need to do the sky division, the synthetic division. K equals -1 tells me that x plus 1 is a factor. -1 goes out front. We got 5, 1, 1, -6. Bring down the 5. Five, 1, 1, -6. I want to make sure I didn't rush anything. That looks good. Which means I should have x plus 1 times my q of x, that's q of x, 5x squared minus 4x plus 5, and then plus my remainder, which is -11. Looks like it matches up. I'll check my answer. Good. So that's kind of like what you can expect in 3.2. It's leading into finding these zeros of the polynomial, which allows us to graph it better. And just try practicing these out. All right. I hope to have another video up for you today, but it might be tomorrow. I need to get some videos up for trigonometry, which doesn't have any yet. If you have any questions, please don't hesitate to email me or use Ask My Instructor in Math Lab, or use that Google text number that I provided earlier in one of the announcements. I'm here for you. I answer questions. All right. Peace. Stop recording. Take care, guys.